Hello and welcome to the first session on FIR filter design. Following are the contents to be covered in this unit of FIR filter design. To start with, a comparison between analog and digital filters, ideal filter requirements, LTI system as a frequency selective filter, then the frequency response of linear phase FIR filters and types of FIR filters type 1, 2, 3, 4. Then design of FIR filters using windowing method, characteristics and comparison of different window functions, and finally the block diagram realization of FIR filters using different structures. The primary references to cover these contents are the book of Procus and I. Fisher. So, what is a filter? Filter is a system or a network that selectively changes the wave shape or amplitude, frequency and phase versus frequency characteristics of a signal. The main objectives of filter is to improve the quality of a signal, to extract information from signal, or to separate more than two signals, wherein one part in the signal can be a noise or there can be altogether two type of signals to be separated out. Typically, what is a digital filter? A digital filter is a mathematical algorithm implemented either in hardware or using software that operates on digital input signal and produces a better quality digital output. So far, you knew the term as a filter in the category of an active filter or a passive filter. An active filter comprises of RLC components with an energy source and op-amp like device, wherein a passive filter contain only the passive components. Whereas in case of digital filter, there are no RLC components as they were in the analog counterpart. The digital filters, they are either directly ported onto a special purpose hardware, that is a DSP processor, or it can be directly a software program wherein the digital filter designing is carried out. So there are two primary categories, analog filters and digital filters. Intentions to design analog filter and digital filter are common, that is primarily to improve the quality of the input signal, where in the analog filter basket the input is in the form of an electrical voltage or current, or can even be captured directly by the sensors. Components being used are RLCs, op-amps as mentioned earlier, and output is in a form of the filtered output. Similarly, in case of digital filter also, a primary set of the design contain input, then a components and output, where the input typically will be obtained from the output of ADC. that is the digitized sample. We are not directly feeding an analog input to the digital filter. Instead, we are first processing it so as to digitize, and then thereafter we are passing it to the digital filter block. In terms of components, it can either be a digital signal processor or can be purely a software program. And output is in a form of filtered samples, and when it is required to be presented in the form of analog filtered output, in that case we are passing it through the digital to analog converter. So in comparison to the analog filters, there are many advantages on the part of digital filters. That is, digital filters primarily are far accurate as compared to analog filters. In case of analog filters, since it makes use of the semiconductor components and the components have tolerances, the values of the components they vary with respect to temperature, humidity, or also due to the aging factor. Such is not the case with digital filters. So there is no drift due to component variations in digital filters, whereas drift due to component variations is quite expected in case of analog filters. Primary advantage on the part of the digital filter is its flexibility in making any kind of variations with respect to the change of design, reprogrammability, whereas the reprogrammability kind of the facility is not available with analog filter. In case of any modification in the design, we have to change the entire design and followed by that the set of the components. Adaptive filtering is one of the biggest advantage on the part of digital filters, which is not possible in analog filters, where adaptive means adopting with respect to the changes in the environment and also due to the time variance, where digital filter adapt to the changes by means of an adaptive algorithms and modify the weights and coefficients of the digital filter. Such kind of the provision is not there in analog filters. Another important advantage on the part of digital filter is a linear phase condition. Linear phase is the variation or the change in the phase response with respect to frequency, which typically using FIR filters we can have a linear response which will reduce the phase distortions. This kind of the advantage, this kind of the provision is not supported in analog filters. In case of digital filters, we need the additional hardware components as in ADC, DAC, DSP processor, wherein such type of the hardware blocks need not be make use in case of